Hello, and welcome to the Yonatech video series. I'm John Yonan, and today we're going to talk about static routing. So what I've done so far is I've created this environment in Packet Tracer. You'll notice that we have San Francisco, Chicago, and New York. This router's in San Francisco, this one in Chicago, this in New York. Now you'll notice that it has 5 separate networks. This represents one network, the 172.16.10 network. This network between the routers between San Francisco and Chicago, which is a serial connection, that's the 172.16.20 network. There is this network here, 172.16.30. Then this network between Chicago and New York is represented by 172.16.40. And this network here is represented, is the New York office, and it's 172.16.50. So it's 10, 20, 30, 40, and 50. Now it really doesn't matter. These could be public IP addressing schemes up here. It really doesn't matter. We've got here a /30 network because we only have 2, it's a point-to-point, so there are only 2 available addresses. Same thing with here, a /30, 2 available addresses. And I've configured everything so everything's working. You'll notice these green lights. So here I've got the serial connection, DCE is here, so I've got the speed of the interface is set here, and here is a DCE to DTE, and the router, the speed is set on that one as well. Now, and then these are /24s. If you don't know what I'm talking about, you should go back and review one of my other videos on IP addressing. So I just wanted to tell you a little bit about, why would someone want to use a static route? Essentially, for static routing, we use this command. It's the IP route command, and it's used to configure the static route. When you set up a static route, you're gonna go into global configuration mode, type in IP route. You'll type in the destination network, the subnet mask, and then the next hop address. So in this case, since we have 5 different networks here, a router will know, because we'll know about its directly connected interfaces and the networks that are directly connected to it, but it won't know about anything beyond that. So let's, for example here, the San Francisco router will know about the 172.16.10 network, and it will know about the 172.16.20 network, but it will have no idea how to get to the 172.16.40, .30, or certainly .50. So we have to set up static route commands, and that is using the IP route command structure. Okay? So why would somebody want to use static routes? Well, it's really essential in small networks where the number of routers and network paths are limited. In static routing, we need to add routes manually with the IP route command. Okay? Now, like any other routing methods, there are pros and cons. So what are the pros? What are the advantages? Well, static routing is fairly easy to implement. You just add these routing commands and you're up and running. It's probably also the most secure way of routing, since there's no information being shared with other routers. If you've got CDP turned off. If you're in an all Cisco environment, you have CDP, the Cisco Discovery Protocol, turned off. You know, it's not really going to be exchanging information at all with all of these other routers, advertising its routes, advertising its networks. So static routing really there's not a lot of processing that's going on when you set up static routing. So there's which is the third issue I wanted to bring up, that very little resources, almost no CPU or memory is used when you set up static routes. So what are the cons? Well, the cons are that static routes only work well and are efficient in a very small network. Once you get many routers and you've got a lot of different static routes set up in your routing tables, it can get very cumbersome. It's hard to read. It's just gets very messy. So another negative would be that if a static route fails, there's no way that it's going to be able to reroute the traffic. Now, there are some tricks that you can use in order to reroute traffic if you have static routes, and that's using something called administrative distances. Let me just bring in this table that shows I'm not going to go into details about administrative distance, but if you have a directly connected interface like this gigabit 0/0 or this serial 0/0/0, that's going to give you a default distance of 0. Now, you'll notice that there are different routing protocols here. Here we have static routes. That's going to give you an administrative distance of 1. The lower the number, the more trusted the number. Okay? So if you had a directly connected interface, that's the most trusted type of interface. If you had an interface that had an administrative distance of 255, that is completely untrusted and is considered non-existent. Okay? And you'll notice some of the more common ones like EIGRP of 90, OSPF 110, RIP 120. These are all common routing protocols. So we also show here the default route command. Now that's sort of like a static route, and we're going to demonstrate that here. Okay? All right. So right now this is all set up. If I were to get onto this computer and try to ping the gigabit 0/0, the 172.16.10.1, well, this is my gateway for this computer. And I can ping this. And I will be able to ping the 172.16.20.1 interface, which is directly part of this router, okay? But I won't be able to ping this interface. And let me demonstrate that. We'll jump on this computer here. Hope you can see this okay. We'll get into command mode. It's kind of small. But let's do a ping. Ping 172.16.10.1, which is my gateway. And I'm getting replies. Now I'm going to ping this interface, the serial interface on this same router, okay? Ping 172.16.20.1. And I get replies. So I can, from this computer, which has an IP of 172.16.10.10, I can get to this interface, and I can get to this interface. Let's see if I can get to this interface, 172.16.20.2. it's going to time out. And why is that? Well, it's because this router knows about this interface or this network. This router knows about this network, and this router knows about this network. But it doesn't know about this network, and it doesn't know about this network. So from this router, I would be able to ping this interface, I would be able to ping this interface, and I would be able to ping this computer. But I would not be able to ping this computer, nor would I be able to ping this computer. So let's just do that. Let's jump on this router. So right now, I can, from this computer, I can get here, I can get here. I'm actually getting here, but because this router doesn't know how to get this thing back to the 172.16.10 network, it's never gonna be sent back through. It just dies. And so let's just ping. Let's get on this router, get into enable mode, also known as privileged exec mode. And from here we can do ping. Now let's ping this interface, 172.16.2.1. I'm sorry, 20.1. My mistake. And that's successful. Let's ping this computer. Up arrow 10.10. Well, it's going to fail. And as I said, the reason it's failing is because it does not know anything about this network. There's no routing protocol to advertise networks that this router is connected to discuss that with other routers. So, how do we fix that? Well, we fix it through static routes. So here's what we're going to do. We're going to fix this one first. Bring this into so that you can see it. Get into privileged exec mode, also known as enable mode. We will get into configuration, global configuration mode. And I just typed in conf t, that's shorthand. You can also type in configuration space terminal, and that will get you into the global configuration mode. And now from here, we want to set up a static route. And you might remember right up here, we're going to enter in the IP route command, the destination IP, the subnet mask, and the next hop address. So we will type IP route. Now the next is the network we want to get to. So let's start out with getting to the 30 network, okay? 172.16.30.0 with a 255.255.2.0. And the next hop is this right here, 172.16.20.2. Hit enter, and that took. Now, we've created a one-way street, okay? If we were to come down here, let's see if we can ping from here to this network here, okay? Let's just give that a try. So we want to ping 172.16.10.10, and it's still dying. Why do you suppose that is? Well, we still need to do more work. we need to configure static routes using the not only to the 30 network, but also to the 40 network and the 50 network. Okay, let's just do that really quickly. So we will type in IP route 172.16.40.0. The next hop address again is 172.16.20.2. Enter, and we'll do IP route 172.16.50.0. And that's also going to go 72.16.20.2. Okay. Now let's save our work. We'll go copy running dash config startup dash config. We could have shortened that by just doing copy space run space start and just hit enter. Alright, so that network is set. Now that router is set. Now let's go on to the next one. Now, let's see if we can ping 172.16.10.10 again. No. Still not working. So we will get into global configuration mode. We will set up IP route. What we want to do is we want to set up a route to the 10 network, right? So it's 172.16.10.0 space 255.0, and our next hop address is this 172.16.20.1. All right. Now let's try pinging over here. And we're successful. All right, and we should be able to ping here from here as well. And we are successful. All right, now let's get these two routes going. Go back in. We're in Chicago. Configure terminal. Okay, now we want to get to the 50 network. It already knows about this network, so we need to get to the 50 network. So we would type in IP route 172.16.50.0 space 255.0 and its next hop, which is right here, .2, right? Now we could also, let's do this a little differently. We could also say out a particular interface. So let's just, rather than having a next hop, we could also put in the outgoing interface. So here we're going to just type in SE, we could type it all out, I guess, serial space 0/0/0 and hit enter. All right, so it's giving us a little message here that says default route without gateway, if not a point-to-point interface, may impact performance. So this isn't the most efficient going this way, okay? And that's okay. I'm comfortable with that. So if we had multiple things, a larger network, then I'd be more concerned. Then we would simply state rather than the serial interface, the outgoing interface, we would state the next hop address, which is more efficient. Okay? Now, last thing is we will set up, oh, and before we get out of here, let's just save our config, okay? So we go copy, here's the shortcut, run, start, okay? Enter, enter. All right, that's saved. Now let's go on to this router. Now this router, you noticed I'm going to use the default route command for this router, okay, rather than the IP route up here statement for static routes. I'm going to use this statement with these zeros and zeros, which is a default route command. Now, why would you want to use a default route? Well, you use that when you want to send all packets destined for any network that's not in your routing table. So if there's something in your routing table, it's going to be routed the way you set it. But if there is no specific destination in your routing table, it's going to be sent out through the interface that you specify as the default route. Okay, and here I'm going to set it to the serial 0/0/1, and that's just like I have here in this example. All right, so let's do that. We're on the New York router. We're going to get into privileged exec mode, and we're going to get into global configuration mode, conf T for short. Then I'm going to type IP route. Now I'm going to do this 0.0.0.0 space 0.0.0.0 space, and then the exit interface, okay? In this case, it's serial. Now you can do it shorthand, which would be SER 0/0/1, and it should take it. All right, so we get another message that says, hey, this isn't the most efficient, may impact performance, no big deal. Let's get out and save our configuration, copy, run, start. All right. Now we should be able to ping everywhere. Let's start out here. We're gonna ping from here over to this interface. All right. Well, no. Let's start with this interface. Have we done that already? No. Let's 30.30. Okay. And we are successful. Now let's ping to this interface. Up arrow 50.50. Hit enter. Has to think about it. Ah, there we go. All right, little ARP caching, getting things going. Now if I were to do that again, it will be instant. So what have we done? We have created a static route because this network knows, this router knows about this network, this router knows about this network, but it does not know about this network, and this network. So we told it how to get places through IP route commands, through this command right here. IP route, the destination network you want to get to, the mask on that network. Now the reason, by the way, I put 252 here is because this is a /30. I could have easily put 252 in the config. I think I put in .0. It will work because there are no other addresses in this network, and we're only going point to point. So, and then of course the next hop address, which is from here to here. This is the next hop, and so that's what I put in. So essentially you're telling all these routers about how to get places, and it works pretty well. I don't think there's anything else for this video. If you have questions, you want to make any comments below, if I've missed something, please reach out and let me know. I'll try to make an update. I would appreciate you liking the page, liking my channel. I'm going to be producing many more videos. If you'd like to learn about something that I haven't covered, please put that in or send me an email. If you have any questions in the future, I'll be happy to answer. I will do my best to get back to everyone. All right, with that said, this has been a long video. I hope you have a great day. Talk to you soon.